Welcome class, 1201 Athena Career Academy. Isn't this so exciting? You get to be a part of my first YouTube video ever. Thought it'd be something more exciting, but it's going to be math. So I thought I'd bring you all into this wonderful world of math. I'm going to be looking in the Clinical Understanding Pharmacology book, and we're going to follow through some of the TTs, the testing, the try this, and I'm just going to do it online for you. You can read it if you want, listen along as you want, try it along as you want, or not. That's up to you. But this is just for you. All right. So, to follow along here, we have want, have, and volume on hand. The want is going to always come from what the doctor orders. Always. Okay, that's always our want. And then what we have, or what the pharmacy gives us, pharmacy has, is going to be our have and our volume on hand. Got that? Is always going to be this right here. Pharmacy has what? Or we have what to give to the patient. And that's a have volume and then a have and then a volume on hand. This equation is what you need to have in your brain. Gotta know this. Want over have times volume. Now there's a number of different ways to set this up, but I think this is one of the easiest, okay? Now again, the only other way that I could show you that you might find this as an easier way to understand it is want times volume on hand over our have. Does everybody see that? Obviously, this is all going to be rhetorical questions because you can't answer me. But want times volume on hand over our have, what the pharmacy gives us as a dose. Okay? A dose of the drug. All right? Go ahead and write that down. Or pause it, because I'm going to erase it. I'm going to give you some equations here. Pharmacy has. All right, so follow along. Doctor orders, so we're going to try page 77, try this, B, TT18B. We want alendronate sodium or Fosamax 5 milligrams, and we have 10 milligram tablets, okay, or 10 milligrams per tablet, but that's what we have, all right? So now we just plug it into the equation of our want times our volume on hand over our have. So want 5 milligrams times our volume on hand, which is tablets, or 1 tablet, over our have of 10 milligrams. Okay? And if you equal that out, you're going to have 5 milligrams, and the milligrams go away, so it's 5 times 1 is 5, divided by 10 gives us 1/2, or 0.5 tablets. 0.5 tablets. Isn't this fun? So much fun. Math is so much fun. All right, so that's a simple example. All right, going on to C, we have Xanax. We're going to change our numbers here a little bit. We have 1.5 milligrams as a dose that the doctor wants us to give to the patient, but the pharmacy has 0.5 milligram tablets. Okay? So again, we just plug this into the equation. Our want times our volume on hand over our have. Want times volume on hand, again 1 tablet. is, if you use a calculator, is going to be 3. So again, our milligrams go away because it's dividing the same thing into itself. Milligrams goes away times tablet gives us an answer of 3 tablets. 3 tablets. Any questions? It's kind of funny to ask online, but here we go. If you do have questions, feel free to email me. All right, and let's do E, okay? Fun numbers. We want to give 0.0625 milligrams, and we have 0.125 milligrams per tablet. Again, just put your numbers into the equation. Our want, 0.0625 milligrams times our volume on hand, again, is 1 tablet, over our have volume of 0.125 milligrams. Now, if you put this into the calculator, it's going to give you, milligrams go away, it's going to give you 1/2 again, because we have 0.125 milligram tablets, and we're only going to give 0.0625 milligrams. So it's going to equal 0.5 tablets. All right, now I'm going to throw you a curveball here, a couple curveballs to get into the conversions. All right. Say the doctor orders 0.25 milligrams of a drug, and we have 125 micrograms per tablet. Okay. What you're going to find here, if we still have to plug the numbers in first. 0.25 milligrams times our 1 tablet over our 125 micrograms. Now the tricky part about this is you can't divide milligrams into micrograms. They have to be the same. So the important part of knowing whether or not you need to do a conversion is if you have the same units. And that's why every time you plug a number into one of these equations, it's got to have a unit next to it. Even tablet still has to have 1 tablet next to it. Okay? So which one do you want to convert? Honestly, it really doesn't matter, because whether you convert milligrams to micrograms or micrograms to milligrams, the equation is going to turn out the same. All right? And I'm going to show you how. And I'm going to bring this over here. All right? Take that same problem, okay? And we want to do 0.25 milligrams, and we want to convert that into micrograms. So we're going to put the milligrams on the bottom and the micrograms on the top. And remember, how we did it today in class is you have the numbers that are just going to go with that. They're never going to change. It's always going to be 1 milligram with 1,000 micrograms. Okay? Now, if we were going milligrams to grams, then grams would have 1 and milligrams would have 1,000. But you have to see the conversion that you're doing and determine which way you're going to go. So we have set it up. We have our units in the right place. They're going to cross off, and we're going to be left with the unit we want to convert to. Now, if we multiply this out, we would be left with 250 micrograms. this. $250 micrograms from over here is going to replace this. And we're just going to change it to 250 micrograms. Now notice, our units are the same now. That's what we're looking for. So now we can do the math. 250 times 1 divided by 125 micrograms gives us an answer of 2 tablets. 2 tablets. I hope everybody sees what we did there. And just in case, we're going to back up, we're going to use the same equation, and I'm going to show you that it doesn't matter which one we convert.